welcome to our deep dive into the world of aviation maintenance.
Okay.
You know, when I think of mechanics, I think of, well, my car.
Right.
But getting a plane off the ground
Yeah.
and keeping it there,
Oh, yeah.
that's a whole other level.
Definitely.
Luckily, the FAA has got a guide for that. The Aviation Maintenance Technician Handbook General.
Oh, yeah.
It's fresh off the press from 2023.
Uh-huh.
And let me tell you, it's chock full of info.
It is a very large book.
Yeah.
A lot of information there.
So much to dig into.
Yeah.
I mean, it covers everything you need to know from deciphering those complicated blueprints
Yeah.
to understanding the physics that make flight possible.
It's true.
I even learned about the never-ending battle against corrosion, something I never really thought about before.
Corrosion is a constant challenge in aviation, especially when you consider all the different environments that these aircraft operate in. If it's not addressed, it can lead to some serious problems.
Oh, for sure.
Even compromised safety.
Okay, so corrosion, got it.
Yeah.
But before we get too far ahead of ourselves, let's rewind to those blueprints.
Okay.
I've always been intimidated by blueprints.
Yeah.
They look like a secret code to me.
They can be a little daunting at first.
Yeah.
Lots of lines and symbols.
What surprised me was how the handbook actually breaks them down.
Yeah.
And makes them understandable.
They do a good job of making it more digestible.
It's not just about, you know, looking at lines. It's about, like you said, understanding the language.
Right. It's a language. They even use the term signposts in the book.
So there are like clues
to
help guide you.
Yeah. And I think that's a great analogy because, you know, if you imagine yourself as an AMT, you're tasked with, you know, replacing a fuel line component. You wouldn't just go in there and start unscrewing things.
Right.
The first thing you do is refer to the drawing.
Got it.
And there's a specific type of drawing called an installation drawing.
An installation drawing.
And this drawing shows you precisely how that component fits within the larger fuel system.
So it's like a roadmap.
It is a roadmap.
For that particular component.
That's a great way to put it.
Okay.
A roadmap.
And here's where those signposts we talked about come in.
Okay.
Things like drawing numbers, reference numbers, and dash numbers.
Exactly. All of those signposts help you pinpoint the exact piece you need to work on.
So you're not like, you know, just randomly grabbing at things.
Right. Because you can imagine how complex these systems can be. There are so many different parts and pieces.
Okay, so I remember you mentioning those signposts earlier.
Yeah.
They help you pinpoint the exact piece you need to work on, right?
Precisely, think of them like a highly detailed treasure map.
Okay.
Guiding you right to the spot.
Got it.
Without these clear markings, it would be easy to get lost in the maze of lines and symbols on a complex blueprint.
That makes sense.
Yeah.
It's all about being precise and making sure you're working on the right part. And speaking of precision, that brings us to another topic.
Okay.
That might make some eyes glaze over physics.
Physics.
But before you tune out, I promise this isn't your high school physics class.
Right. Yeah.
The handbook makes it so much more interesting by directly relating it to aircraft and what AMTs need to know.
It's all about application.
Yes.
You know, it's not just about memorizing formulas. It's
Right.
about understanding how those formulas translate into the real world of aviation.
Yeah.
For instance, you probably know that when you fly, your ears sometimes pop.
Oh, yeah.
Due to pressure changes.
Totally.
Well, that's physics in action.
Okay.
Specifically something called Boyle's Law.
Okay, so Boyle's Law is responsible for my ears popping.
It is.
Tell me more.
So Boyle's Law basically explains that as the volume of a container decreases, the pressure inside increases.
Okay.
Assuming the temperature stays the same.
Okay.
Now think about an airplane cabin as that container.
Oh, I'm picturing it.
As the plane climbs and the altitude increases, the air pressure outside decreases.
Right, yeah.
But the cabin needs to maintain a certain pressure for passengers to be comfortable.
So the cabin is like a sealed container.
It is a sealed container.
And as we go higher, the volume of air inside is technically shrinking.
Right.
Leading to that increase in pressure.
Exactly. So AMTs need to understand this principle.
To make sure
the pressurization system is working correct. Keeping everyone on board safe and comfortable.
That's a great example of how physics isn't just some abstract concept.
Right.
It's really the foundation for understanding how these amazing flying machines work. And of course, why maintenance is so critical.
Absolutely.
Okay, let's shift gears now.
Okay.
And talk about a challenge that I never really considered before.
All right, corrosion.
Corrosion.
Yeah.
It's a silent but serious threat to aircraft.
Especially, you know, again, when you consider the environments they fly in.
Right.
rain, salt water, extreme temperatures.
Yeah.
If left unchecked,
Yeah.
corrosion can weaken critical parts of the plane.
Absolutely.
It can lead to all sorts of problems.
So the handbook dives into the different types of corrosion that can affect aircraft, focusing specifically on aluminum, magnesium, and titanium.
Right. Those are the most common materials used in aircraft construction.
I was surprised to learn that even something as simple as using the wrong tool can make a big difference.
Absolutely.
Really?
Yeah. Using the wrong tool can actually accelerate corrosion.
Wow.
So, for example, using steel tools on magnesium is a big no-no.
Got it.
You don't want to do that.
It's amazing how these seemingly small details can have a huge impact on aircraft safety.
It's all about the details.
So how do AMTs stay ahead of this corrosion problem?
Well, prevention is key.
Prevention
is key.
Okay.
The handbook emphasizes meticulous cleaning to remove any contaminants that can contribute to corrosion.
So it's like keeping a spotless kitchen.
It is like keeping a spotless kitchen.
Yeah?
Yeah, think about it.
Yeah?
If you have a dirty kitchen, things are going to start to rust and corrode.
Yeah, it's true.
Same thing with an airplane.
And just like you'd apply a sealant to protect your countertops, aircraft are protected with special coatings.
Exactly. It's all about creating a barrier against the elements.
So it's a combination of good housekeeping and creating a barrier against the elements.
It is a combination of those two things.
Okay, so we've covered blueprints, a bit of physics, and the constant battle against corrosion.
Yeah.
Now let's get into something that even someone who can barely change a light bulb, find fascinating: electrical systems.
All right, electrical systems, they can seem daunting.
Yeah.
But the handbook really does a great job of breaking them down.
Yeah.
It starts with the very basics.
Okay.
Static versus dynamic electricity magnetism. And something called Ohm's law.
You know, I vaguely remember Ohm's law from somewhere back in my school days. I never really grasped its importance, though.
Right.
Why is it so crucial for an AMT to have a solid understanding of this concept?
So Ohm's law basically describes the relationship between voltage, current, and resistance in an electrical circuit.
Got it.
It's like the fundamental equation that unlocks the secrets of how electricity flows.
So if I'm picturing this correctly, the higher the voltage, the more push the electricity has.
That's a good way to think about it.
And the higher the resistance, the more it's being held back.
You got it.
Okay.
So AMTs use Ohm's law to troubleshoot electrical problems.
Right.
Figure out the right size wiring to use, and basically understand how electricity is behaving throughout the entire aircraft.
Okay, that makes much more sense now.
Good.
It's like having the key to decipher what's happening within those intricate electrical circuits.
That's right.
And from there, the handbook moves on to more complex components, like capacitors. Capacitors. Now, those are interesting.
They are.
I remember playing with them in science kits as a kid.
Yeah.
But I have no idea what they actually do in an aircraft.
So in simple terms, a capacitor stores electrical energy.
Okay.
Think of it like a tiny battery that can release its stored energy very quickly.
Oh.
And there are many different types of capacitors.
Oh, really?
Yeah.
So like different tools for different jobs?
Precisely.
Okay.
And knowing which capacitor to use and how it will behave in a circuit is essential for an AMT.
Right.
For instance, electrolytic capacitors have a specific polarity. Think of it like a positive and negative side.
Got it.
And installing them backward can lead to some serious issues.
Yikes. Better double check that handbook then.
Yeah, always a good idea to double check.
It's clear that understanding these details isn't just about passing a test.
Right.
It's about keeping those planes flying safely.
That's all about safety.
Absolutely.
Absolutely.
Speaking of which, let's move on to a topic.
Okay.
That's all about those little details. Fasteners.
Fasteners.
I never thought I'd find nuts and bolts so interesting.
Right.
I always thought it was just a matter of tightening things up until they were, tight.
Yeah, you'd think it's pretty straightforward.
But this handbook opened my eyes to a whole world of different fasteners.
There is.
Each with its own specific purpose.
Fasteners are literally what hold an aircraft together.
Wow.
So their importance cannot be overstated.
Yeah.
And as you've discovered, there's a lot more to it than just grabbing any old bolt and tightening it down.
Right. The handbook talks about close tolerance bolts, for example.
Yes.
Those are the ones where the fit has to be extremely precise, right?
That's right.
Why is that level of precision so critical in aircraft construction?
So close tolerance bolts are designed for applications where even the slightest movement or vibration can cause problems. Think of them as the high security bolts of the fastener world. They're used in areas where structural integrity is paramount.
Okay, so you can't just swap in a regular bolt for a close tolerance bolt.
Definitely not. Imagine using a regular bolt in a critical part of the wing structure, where a close tolerance bolt is required. Over time, with the constant stress and vibration of flight, that bolt could loosen or even fail.
Oh, wow.
And the consequences of that could be disastrous.
Okay, I'm starting to understand the gravity of using the right fastener for the job.
Yeah, it's not something to take lightly.
And then there's safety wire, which always sounded so mysterious to me.
Safety wire.
What's its role in all of this?
So safety wire is essentially an extra layer of insurance to prevent those crucial bolts and nuts from loosening. It's like a safety net for fasteners.
I like that.
Especially in areas prone to vibration.
So it's not just about brute force tightening. It's about understanding the physics of how things move and vibrate and then taking steps to counteract those forces.
Exactly. And that's what makes the work of an AMT so fascinating.
Yeah.
It's a blend of technical skill, scientific knowledge, and a meticulous attention to detail.
You know, I'm starting to see a recurring theme here.
What's that?
Precision and attention to detail.
Precision and attention to detail. Those are two key ingredients.
And speaking of precision, that leads us to another crucial aspect of aviation maintenance. Weight and balance.
Weight and balance. Yeah, that's a big one.
Yeah.
It's a concept that's crucial for the safe operation of any aircraft. You can think of it like finding the perfect balance point on a seesaw.
Okay, I'm picturing that too much weight on one side and the whole thing tips over.
Right.
But how does this relate to an airplane?
So every aircraft has a designated center of gravity, or CG, range where it needs to be balanced for safe flight. It's like finding the sweet spot where the plane flies most efficiently and safely.
So if the CG is off, it could affect the plane's handling and stability?
Exactly. And calculating the CG involves taking into account the weight of everything on board. Passengers' baggage, cargo fuel, even the aircraft itself.
Wow.
And its distance from a reference point.
It sounds like a complex equation with a lot of variables.
It can be, but AMTs use specific procedures and charts to make these calculations. The handbook actually uses a simple example. Imagine a plank balanced on a fulcrum. By adjusting the weights placed on the plank and their distances from the fulcrum, you can find the point where the plank balances perfectly.
So it's like a scaled down version of what's happening with an aircraft.
Exactly. And if the calculations show that the aircraft's CG is outside the acceptable range, AMTs might need to add ballast to adjust the weight distribution.
Ballast like those sandbags they use in hot air balloons.
Similar concept. It's all about strategically adding or removing weight to achieve the desired balance.
Interesting.
Now, while we're on the topic of things that could potentially throw off an aircraft's balance, let's shift gears and talk about ground operations, specifically fueling.
You know, I've always wondered about that. It's not like they can just pull up to a gas station and fill her up, right?
Definitely not. Fueling an aircraft is a highly controlled process with a lot of safety precautions in place.
Well, yeah, given that we're talking about thousands of gallons of highly flammable fuel.
Right, exactly.
What kind of precautions are we talking about?
So before fueling even begins, all electrical systems and electronic devices on the aircraft have to be switched off.
Makes sense. Sparks and fuel are a bad combination.
Exactly. The handbook even goes so far as to say that personnel involved in fueling should avoid carrying anything in their shirt pockets.
Wow. Why is that?
It's all about minimizing potential hazards. Even a small item, like a pen or a tool, could fall into the fuel tank and cause problems.
Okay. That's an incredible level of attention to detail that I never would have considered.
Yeah.
So fueling is clearly a delicate operation.
It is.
What about securing the aircraft once it's parked? I've always pictured those ropes being tied down really tight.
There's a bit more to it than that. The handbook goes into detail about the importance of using the correct tie-down procedures. Taking into account the type of aircraft, the weather conditions, and even the type of knot used.
Wait, the type of knot matters?
Absolutely. You wouldn't want to use a knot that could easily come loose in strong winds.
Right.
The handbook specifically recommends using anti-slip knots, like the bowline.
So it's not just about brute strength. It's about understanding the forces at play and using the right techniques to counteract them.
Precisely. It all comes back to that blend of practical skill and scientific understanding that we keep talking about.
Yeah.
And speaking of potential dangers and how to mitigate them, let's move on to a crucial topic, fire safety.
Fire safety. Now, that's something I definitely don't want to mess around with, especially when it comes to airplanes.
Right.
What does the handbook say about fire extinguishers?
The handbook provides a comprehensive overview of different types of fire extinguishers,
Okay.
their classifications, and the types of fires they're designed to combat.
You know, I've always seen those letter and number codes on fire extinguishers, but never really understood what they meant.
So those codes are a quick way to identify which type of fire the extinguisher is intended for.
Got it.
Class A is for ordinary combustibles like wood and paper.
Okay.
Class B is for flammable liquids. Class C is for electrical fires. And Class D is for flammable metals.
So you need to use the right extinguisher for the right type of fire.
Exactly.
It's not a one-size-fits-all situation.
It is not.
Okay, good to know. But here's a question that just popped into my head. Are there any types of fire extinguishers that you should never use on an aircraft fire?
That's a great question, and the handbook actually addresses this directly.
Okay.
It has a very clear warning against using carbon tetrachloride, also known as Halon 104.
Halon 104, what's the problem with that one?
Halon 104 is extremely toxic and can produce deadly gases when used on a fire. It's definitely something you don't want anywhere near an aircraft.
Yikes. That's good to know. It sounds like fire safety is a serious business in aviation.
It is.
And rightly so. But let's shift gears now and talk about something that might not seem as dramatic as fire extinguishers, but is equally important, aircraft documentation.
Aircraft documentation, might not be the most glamorous aspect of aviation maintenance.
Right.
But it's absolutely essential.
I imagine there's a lot of paperwork involved in keeping track of everything that's done to an aircraft.
You're right. Detailed documentation is crucial for tracking maintenance, ensuring airworthiness, and maintaining a complete history of the aircraft. It's like a medical record for the plane.
Okay, so every checkup, every repair, everything gets logged.
Exactly. The handbook covers different types of aircraft logs, including the aircraft logbook, engine logbook, and propeller logbook.
So each major component has its own log.
They do.
That makes sense. What kind of information is recorded in these logs?
So these logs record a wide range of information, including dates of inspections, descriptions of work performed, the identity of the person who did the work, and any parts or components that were replaced.
Wow. So it's a really comprehensive record of everything that's been done to the aircraft throughout its life.
Precisely, this documentation is essential for proving that maintenance has been carried out correctly and that the aircraft is airworthy.
And speaking of ensuring airworthiness, let's talk about inspections.
Inspections.
Now, these are something I've always associated with my car.
Yeah.
You know, those annual checkups to make sure everything's running smoothly.
Right.
Are aircraft inspections similar?
In some ways, yes. The FAA requires regular inspections to ensure the ongoing airworthiness of aircraft.
Okay.
The handbook mentions annual inspections and 100-hour inspections.
So those are like the standard checkups for planes.
Exactly. The annual inspection is a more comprehensive nose-to-tail checkup, while the 100-hour inspection is typically required for aircraft that are used for hire or flight instruction.
Are there any differences in terms of who can perform these inspections?
Yes, there are. A certified airframe and power plant mechanic, or A&P mechanic, can perform a 100-hour inspection.
Okay.
But an annual inspection must be conducted by an A&P mechanic with an inspection authorization.
An inspection authorization? What's that?
It's an additional certification that allows an A&P mechanic to approve an aircraft for return to service after an annual inspection.
Okay.
They have the authority to sign off on the aircraft's airworthiness.
That sounds like a pretty big responsibility.
It is. It requires extensive knowledge, experience, and a deep understanding of aviation regulations.
Yeah.
Now, aside from these regular inspections, there are also specific inspections required after certain events.
What kind of events are we talking about?
Things like a hard landing or a bird strike.
Ah, that makes sense. Those events could potentially cause damage that needs to be assessed.
Exactly. The handbook outlines the procedures for these specific inspections, which are designed to identify any potential damage that may have occurred during those incidents.
Got it.
It's all about being proactive and ensuring that any potential issues are caught early on. Speaking of being proactive, let's talk about another crucial aspect of being an AMT.
Okay.
Staying up to date with the latest information.
That's a great point. Aviation is constantly evolving with new technologies and procedures emerging all the time.
Yeah.
How do AMTs keep their knowledge current?
So the handbook highlights several important resources for staying informed. These include advisory circulars, or ACs,
Okay.
airworthiness directives, or ADs, service bulletins, or SBs,
Okay.
and manufacturers' maintenance manuals.
Okay, that's a lot of acronyms.
Yeah.
Can you break those down for me? What's the difference between an AC and an AD, for example?
So advisory circulars provide guidance and recommendations on specific topics or regulations. They're like helpful tips and best practices.
Okay.
Airworthiness directives, on the other hand, are mandatory instructions issued by the FAA to address safety issues.
So ADs are the ones you absolutely have to follow, no questions asked.
Exactly. They usually involve specific actions that need to be taken to fix a known safety problem.
Got it.
Then there are service bulletins, which provide information on recommended repairs or modifications.
So SBs are more like suggestions from the manufacturer.
That's a good way to think about it. They're not mandatory.
Okay.
But they often contain valuable information that can improve safety and performance. And finally, there are the manufacturer's maintenance manuals, which provide detailed instructions on how to maintain specific aircraft models.
So it sounds like AMTs need to be familiar with all these different sources of information.
They do.
And know where to find what they need.
That's right.
But is there a system for organizing all this information so it's not just a jumbled mess?
There is. The handbook mentions something called the ATA iSpec 2200.
ATA iSpec 2200. That's pretty techno. What is it?
It's a standardized system for organizing aircraft maintenance information.
Okay.
Think of it like the Dewey Decimal System for airplanes.
I love that analogy.
So instead of searching through mountains of documents,
Right.
AMTs can use the system to quickly find what they need.
So the ATA iSpec 2200 divides the aircraft into systems, subsystems, and components.
It does.
Using a numerical coding system.
Right.
Okay, so let's say I'm looking for information on the landing gear system.
Right.
Would there be a specific code for that?
Yes, there would be. Each subsystem and component has a unique code,
Okay.
making it much easier to find the relevant documentation.
That's incredibly helpful. It's all about streamlining the maintenance process and making sure that information is easily accessible.
It is.
Now, speaking of accessing information that's not readily visible,
Okay.
let's talk about a topic that sounds pretty high-tech, non-destructive testing.
Non-destructive testing, or NDT, is a way to inspect aircraft components for flaws without causing any damage to the parts themselves.
So it's like a medical imaging for airplanes.
That's a great way to put it. The handbook covers several NDT methods, including liquid penetrant inspection, eddy current inspection, ultrasonic inspection, magnetic particle inspection, and radiography.
Wow, that's a whole arsenal of inspection techniques. Can you give me a brief overview of what each one does?
Absolutely. Let's start with liquid penetrant inspection. It's used to detect surface cracks in non-porous materials.
Okay.
Basically, a special dye is applied to the surface of the component, and the dye seeps into any cracks that are present.
Okay.
Then the excess dye is removed, and a developer is applied. The developer draws the dye out of the cracks, making them visible to the inspector.
So it's like highlighting those tiny cracks so they can't hide.
Exactly. Then there's eddy current inspection, which uses electromagnetic fields to detect flaws in conductive materials. It's particularly good at finding cracks or corrosion beneath the surface.
So it's like having X-ray vision for metal parts.
You could say that ultrasonic inspection uses high-frequency sound waves to detect internal flaws.
Okay.
It's similar to how doctors use ultrasound to see inside the human body. Then there's magnetic particle inspection, which uses magnetic fields to detect surface and near-surface flaws in ferromagnetic materials. And finally, there's radiography, which uses X-rays or gamma rays to create images of internal structures revealing any hidden flaws.
It's amazing how science and technology have come together to create these sophisticated inspection methods that can literally see through solid objects.
Yeah, it's pretty amazing.
But let's not forget about the tools that are essential for any AMT.
All right.
The trusty hand tools.
Hand tools, yes. They are the foundation of aviation maintenance.
They are.
While power tools and advanced technology certainly play a role, a skilled AMT still needs to know how to use basic hand tools effectively.
It's like a chef needing to know how to use a knife before they can operate a food processor.
That's a great analogy. The handbook covers the proper use and care of hand tools, emphasizing safety and precision, for instance, when using a wrench. It's important to select the right size for the job, and to avoid using excessive force that could damage the fastener or the tool itself.
It's all about respecting the tools and using them properly to achieve the best results. And that attention to detail, knowing the right way to use each tool, is what sets a skilled AMT apart.
Absolutely.
But we've only scratched the surface of what AMTs do.
We have.
Let's dive into some of the more specialized areas of aviation maintenance.
Okay, let's do it.
Welcome back to our deep dive into the world of aviation maintenance. We've covered a lot of ground already, from the importance of meticulous documentation to those incredible non-destructive testing methods that can practically see through solid objects.
It's amazing how much goes into keeping those planes flying safely and efficiently, but we've only just scratched the surface of what AMTs need to know and do. Let's delve into some of the more specialized skills that these aviation wizards possess.
Okay, I'm ready to be amazed. Let's start with sheet metal work. I know this involves working with thin sheets of metal, but what exactly does it entail in the context of aircraft maintenance?
Sheet metal work is all about shaping and forming those thin sheets of metal to create or repair aircraft components. It's a bit like sculpting, but with metal instead of clay.
I can picture that carefully bending and shaping the metal to fit the contours of the aircraft. It must require a steady hand and a lot of patience.
Precision and patience are definitely key. AMTs use specialized tools like rivet guns, sheet metal brakes, and shrinker stretchers to manipulate the metal with incredible accuracy.
Shrinker stretchers. Those sound intriguing.
They're amazing tools. Imagine you need to make a curved piece of metal for the fuselage of an aircraft. A shrinker stretcher allows you to either shrink or stretch the metal along a specific line, creating that perfect curve. It's a bit like magic watching a skilled AMT use these tools.
It sounds like a blend of artistry and engineering, taking a flat sheet of metal and transforming it into a precise three-dimensional component.
Yeah.
But it's not just about shaping the metal, right? You also need to join those pieces together. What methods are used for that?
The handbook covers a range of joining techniques, from basic hand forming to more advanced methods like riveting and welding.
Riveting, like those little metal fasteners you see all over an aircraft skin. How do those work?
A rivet is essentially a metal pin with a head on one end. The AMT uses a special tool called a rivet gun to drive the rivet through the pieces of metal being joined. The rivet gun then deforms the other end of the rivet, creating a second head that holds the pieces together tightly.
So it's like a really strong, permanent fastener.
Exactly. Rivets are incredibly durable and can withstand the stresses of flight, and they're used extensively in aircraft construction. Now, another essential joining method is welding.
Welding, that always seemed like a pretty intense skill to master, involving lots of heat and sparks.
Welding is definitely a skilled trade. It involves using heat and pressure to fuse metals together, creating a strong, permanent bond.
What are some of the different welding methods used in aviation maintenance?
The handbook mentions several methods, including gas welding, arc welding, and TIG welding. Each method has its own advantages and is suited for different types of metals and applications.
What about safety precautions? Welding seems like it could be pretty hazardous.
You're right. Welding can be dangerous if not done correctly. That's why the handbook emphasizes the importance of wearing proper safety gear: a welding helmet to protect your eyes from the intense light, gloves to protect your hands from burns, and a fire-resistant jacket.
It's a good reminder that safety is paramount in every aspect of aviation maintenance, no matter how big or small the task. But let's shift gears now and talk about a material that's become increasingly important in modern aircraft composites.
Composites are those lightweight, high-strength materials you often find in aircraft wings and fuselages. They're made by combining two or more different materials, kind of like baking a cake with different ingredients to create something new and better.
I know composites are known for their strength and lightness, but what are their advantages over traditional materials like aluminum?
Composites are incredibly strong for their weight, which helps improve fuel efficiency. They're also resistant to fatigue and corrosion, which are major concerns with metal aircraft.
So composites sound like the perfect material for aircraft. Are there any downsides?
Well, working with composites requires a different set of skills and techniques compared to working with metals, and repairs can be more complex and time-consuming. One of the things the handbook emphasizes is the importance of avoiding contamination when working with composites.
Contamination. What do you mean by that?
Even tiny amounts of dirt, grease, or other foreign substances can weaken the bond between the composite layers. It's like having a crumb in your cake batter that prevents the cake from rising properly.
So it's all about cleanliness and precision.
Exactly. And the repair procedures can vary depending on the specific type of composite material and the extent of the damage. That's why the handbook stresses the importance of following the manufacturer's instructions meticulously.
Okay, it sounds like working with composites is a whole other level of expertise for AMTs.
Yeah.
But before we wrap up our deep dive, I want to touch on a topic that's essential for any AMT, regardless of their specialization: understanding technical publications.
Technical publications are the lifeblood of aviation maintenance. They provide AMTs with the information they need to do their jobs safely and effectively.
What kind of information are we talking about?
Everything from detailed maintenance manuals and parts catalogs to service bulletins and airworthiness directives, those mandatory instructions we talked about earlier.
So it's a vast library of knowledge that covers every aspect of aircraft maintenance.
Exactly. And these publications are written in a standardized format and language making it easier for AMTs to find the information they need quickly.
I can see how that would be crucial, especially when you're dealing with complex systems and procedures.
And the handbook stresses the importance of using the most up-to-date publications. Information can change over time, so relying on outdated information can lead to mistakes and compromise safety.
That makes sense. You wouldn't want to be using a 10-year-old map to navigate a city that's constantly changing.
Exactly. It's all about staying current and informed.
Well, we've covered an incredible amount of ground today, from the basics of blueprint reading to the intricacies of composite repairs and the importance of staying up to date with technical publications.
It's been quite a journey through the world of aviation maintenance, and I think you've captured the essence of what makes this field so fascinating. It's a constant blend of technical skill, problem solving, and a deep commitment to safety.
You know, I have a whole new appreciation for the work that AMTs do. They're the unsung heroes who keep us soaring through the skies. And next time I board a plane, I'll definitely be thinking about all the meticulous work that goes on behind the scenes to ensure a safe and smooth flight.
I think that's a great takeaway from our deep dive. AMTs are the guardians of aviation safety, working tirelessly to keep those planes in tip-top shape.
And if anyone out there is intrigued by the world of aviation maintenance, I highly recommend exploring the Aviation Maintenance Technician Handbook. It's a fascinating and rewarding field full of challenges and opportunities.
Well said. And remember, whether you're a seasoned AMT or just starting your aviation journey, there's always something new to learn and discover in this amazing field.
Until next time, keep exploring, keep learning, and keep those wings level.
Safe travels, everyone.